Okay, we have got a lot of information again. So it tells us that sucrose is a carbohydrate, and we are taking this sucrose and fermenting it. And when we do that, it produces ethanol and carbon dioxide. It's then talking about an experiment. We've got 100 grams of sucrose. The yeast has been added to allow it to ferment, and we get the gas carbon dioxide starting to form. Ethanol is also obtained, and here we've got some information showing us the values, the mass of each of those bits. So here we've got the mass that was obtained, and this is the theoretical mass. Okay, so the first thing we've got to do is state the meaning of actual and theoretical yield. So actual yield is the amount of product produced by the chemical reaction. The theoretical amount is the mass of chemical which should be obtained according, hang on, start that again for you. I don't know what to write now. According to the balanced chemical equation. So that's a theoretical amount that we are calculating. Use the information to calculate percentage yield. So percentage yield, and here they've tried to help us. They've given us the equation, so it's the actual. So the actual in here is 8.07. The theoretical is this 53.08, and then we multiply the whole thing by 100. Let me work that out on my calculator. So it's 8.07 divided by 53.08, and I'm going to times the whole thing by 100. So here I'm getting an answer of 15%. Just check, does it want me to give it to any particular decimal places? It doesn't. There are 2 marks, so you are going to score 1 mark for getting these numbers in the right order, and then 1 mark here for getting your answer correct. Give 2 reasons why it's less than 100%. So it's less than 100% because you can get unwanted side reactions, so they can take place. You can get incomplete reactions, so not all the chemicals react fully. You only need 2, so there's 2. We know there's 3 options here. The third option in this situation is that some of the chemicals are lost during the experiment. As I said, you only need 2, so if you've written these first 2, a mark for each of those. Okay, next little bit, let's have a look. It wants us now to work out the atom economy. So atom economy in this type of reaction, I'm just going to show it to AE. What we have to do is understand what the desired product is, and it wants us to calculate the atom economy for ethanol. So there is my ethanol. So if I'm going to work this out, I've actually got 4 lots, because the equation's got 4 there. I've got 4 lots of ethanol, and ethanol is 46. So my first calculation to do is work that out. Underneath, I then got to work out the mass of all the products. So I've still got 4 lots of ethanol, so I've got 4 times 46, and then we're going to add 4 lots, so it's 4 times the mass of carbon dioxide, which is 44. 4 times 44, and then we times the whole thing by 100. And it wants us to give an answer to 2 significant figures. So let me put all that into my calculator. So I've got 4 times 46 divided by 4 times 46 plus 4 times 44. Okay, put that into my calculator. I'm getting an answer here of 51.1, but I've got to do to two significant figures, which therefore becomes 51. Marks wise, 4 marks available, or 3 marks available, so you get 1 mark for doing this. You're going to get a mark in here for the top little bit and a mark in here for the bottom little bit as well. Describe what happens if the company make the carbon dioxide into fizzy drinks. If we do that, that makes the carbon dioxide desirable. If I just come back up to the equation, that means that both the ethanol and the carbon dioxide are now desirable, and therefore my atom economy would become 100%. So what would happen is it would become 100%. Why does it do that? Because both products are now desirable, and you're going to get a mark for that and a mark for that.